This screencast will talk about temperature regulation and the connection between the nervous and integumentary systems in maintaining our body temperature. It's very important to maintain our internal body temperature because slight shifts can disturb metabolic functions. So all the functions within our body work best at specific temperatures. And so our body needs to keep that temperature right in that normal range near the set point. Heat loss has to be balanced by heat production. So our muscles produce the most heat within our body. We can do that voluntarily, but our body also loses heat, and so we need to balance those two things. The skin is going to play a major role in homeostasis, specifically thermoregulation, which is regulating body temperature. So our body is going to regulate temperature through two main ways. Blood vessels that communicate. You can see here the brain is communicating with the skin. So blood vessels and sweat glands, which are very important. When we talk about our blood vessels, we're going to talk about vasodilation and vasoconstriction. Vaso means blood vessel, and so vasoconstriction is when the blood vessel gets narrower. Vasodilation is when the smooth muscle makes the diameter of the blood vessel get wider on the inside. So when we talk about cooling the body, so if our temperature gets too high, we're going to sweat firstly. So through sweating, our body produces sweat, which is, of course, a liquid. It evaporates, which cools the body down. In vasodilation, you can see here that these blood vessels that are close to the skin are going to get wider. Because they get wider, there's more surface area in contact with the upper layers, the superficial layers of the skin, and so heat is going to be lost from the blood via radiation to the environment. On the opposite side, we have three mechanisms to warm. So the first thing is that sweat production will stop. So the sweat glands will stop producing sweat so that you don't lose heat through evaporation. The second is vasoconstriction. So our blood vessels will narrow in order to keep blood closer to our core and away from our skin. And lastly, remember that muscle contraction is what produces the most heat, and so we'll have slight muscle contractions, which are going to result in shivering. So if we look at a generic feedback loop here, we have some sort of initiation of an event or a stimulus. It's going to impact a variable. In this case, we're talking about temperature being the variable. Thermoreceptors are going to detect the change in temperature, send that information to the control center. For temperature, it's the hypothalamus within the brain, and that's going to be compared to a set point. Make sure this temperature is where it should be. It's after comparing to the set point, we're going to make a decision. This is a decision made by your control center, not by you consciously, in order to either heat or cool the body if necessary. If we need to heat or cool the body, that message is going to be sent to the effectors. The effectors, again, are your sweat glands, your blood vessels, or your muscles that'll shiver, and that effectors will make the change in order to adjust the variable. The variable will change, receptors detect that, and that message gets sent again, compare it again to the set point, and decide if we need to keep doing what we were doing or do something different. So that is a brief overview of how feedback loops work within the integumentary system to control body temperature and maintain homeostasis.